Today we're going to be setting up a branch office for my home lab. A branch office is, well, a location for a business physically different than its main headquarters. Think your local bank branch, for example. But it takes on a meaning of its own in the IT and networking world because you need to worry about how to get the main office's network to all your branch offices. And ideally, you're remotely managing that branch office equipment from the main headquarters so you don't have to get IT folks staffed up all over the country. I've been building up what I'm calling my Retrorack, and I haven't worked on it for quite some time. I thought it'd be fun to use that as my main office and build a couple little branch offices here, the same way someone might have done it back in the early 2000s, late 90s. So what's the plan here? Well, we're going to get a point-to-point link between this branch office in here and the main office, my server in the other room. And we'll start with a really simple Ethernet point-to-point link over fiber between this big old 7206 Cisco router and the one I've got in the other room. But this huge 7200 over here isn't very realistic when we're talking like a branch office with 5 employees or something. This is like borderline ISP grade gear, as you'll see. So we'll build another branch office with some more humbler gear here and a humbler connection. T1. These are some smaller Cisco 1600 and 1700 series routers, I think from the very early 2000s. This is much more realistic for what you'd see in a small office with just a handful of employees linked back to the main office. And like I was saying, we'll build this in a slightly more realistic way over a 1.5 megabit per second T1 connection from the main server rack over to this branch office gear. Then we'll see why none of that is all that realistic at all from a branch office perspective. I'm in an awkward situation down here. I'm my own ISP. Normally you'd have an ISP in the middle of all this, and we'll go over my plans for future videos to build this up and have some dedicated infrastructure pretending to be an ISP a little more realistically. Probably leveraging some of this huge ATM or asynchronous transfer mode networking gear, also running over fiber. Let's get into it. Let's get familiar with what I'm calling the Retrorack, or the main office, for the duration of this video. You can see the top here, and I'll pan you to the bottom. It is very large. Most of what we're going to be dealing with is all at the top here. This is actually a dial-up ISP in one router. This is a Cisco 3700. We won't be using this today, but eventually I'd like to use this for dial-in remote management capabilities. This thing can provide phone lines and actually allow me to dial up with modems elsewhere and get into this rack. So that'll be another video. Got some very simple power distribution here, only a couple things on. This is a Cisco 2500 series router, but I'm using it as what's called a terminal server. It has a squid cable coming off the back, which actually breaks out into 8 serial connections. You manage most of this network infrastructure over a serial console. It's a serial connection, but they typically use these RJ45 cables because those would be plentiful and easy to route in the data center. This thing lets me hook up to 8 devices in the rack over serial, and I can remotely manage it in the other room over my network. We'll be doing that a lot today. The heart of the operation is the Cisco 7206 series VXR. This is a very serious piece of equipment, especially if we're talking early 2000s. The joke was that VXR stands for very expensive router. And yeah, depending on how you get these what are called port adapters decked out, we'll do a lot of that today as well. These could be insanely expensive, tens of thousands of dollars. The switch to hook up other machines into this basic network I've got here, this is running a 10.0.0.0 network, I believe. So that'll be our main office network that the branches need to connect back to. This switch is a Catalyst 3550 switch. Nothing too special here. Good switch though. One of the reasons I wanted to do this is I always come and play with this stuff and mess around with it and forget how I left it. And so the idea here is to iteratively get this thing into a usable state that I've documented and I remember, and I can just come in here and power everything up. So that's all of this stuff on. On the back of this big guy, we've got Ethernet connections that we're going to leverage for our point-to-point. We'll run that into the room I was just in. And then down here, you can see this Sunfire V240 server. Its remote management is up and powered, though the server itself is not powered on. This is hosting the Sunray server software. Sunrays are Sun Microsystems thin clients from the late 90s into the mid 2000s, and I think we're going to need some of those in our branch offices. So now that we're acquainted with this, let's go get into the terminal and see what our big guy is doing. I cannot remember how anything is hooked up, and we'll go from there. Okay, that took me a moment to refresh my memory on what's going on here. So I'm back in the workshop on my main machine. It has two network interfaces. One of them is going to my main server rack, 192.168.1.0 network. Another one gives it an IP on the Retrorack. And what we can do is telnet into that terminal server I was showing you, which has the squid cable coming off the back. Each of those legs of the squid is exposed as a port. The second one is plugged in to the main VXR router. So I can telnet in, and here I am configuring that router. Let's do the basic command you need to know on Cisco iOS. This is saying, show me all the IP interfaces and be brief about it. So there we go. I've got my 1 gigabit Ethernet interface on the back. That's the router itself. It's plugged in to the switch. I'm sure this is making perfect sense. We are going to make a point-to-point connection between one of its other gigabit Ethernet ports and our branch office in here. Now that I know this is up and working, and I'll show more diagrams as we go so that hopefully you can follow along, let's take a look at this other Cisco 7200 series router that we're going to hook up and get to know it a little better. This is a Cisco 7200 series router, a 7206 to be precise. You can tell the model number by the number of ports it has. So mine has 1, 2, 3, 4, 5, 6 ports. I've got a double width card, a very interesting one we'll look at. 6 total ports. They made a 7204. And notice this one doesn't say VXR. The VXR line came out a little later. It's a little more powerful. If you're not familiar with these things, well, about 5 minutes from now, you're gonna want 5 of them. They have these things called port adapters. You unlock them, and they are modular. So this one happens to be a T1 card. I've got this fast Ethernet over fiber card over here. You can get ATM cards, T3 cards, pretty much anything you could imagine. And I was mentioning earlier that it's not very realistic as your router sitting in your small little branch office. It's really meant for like WAN aggregation. That's why it has all these different types of inputs. Proper use would be in my main office example where you've got T1 coming from one office, you've got an ATM link coming from another, and so on and so on. I think I was just storing cards in this thing. I've got fast Ethernet right here. These two are token ring cards, so you can do token ring over this thing. I'm going to pull out all the stuff we don't need to simplify things. I'm going to let you in on a little secret. Part of filming this video is so I have an excuse to play with a bunch of stuff that I haven't really messed around with. Notice this one is a double width card. Little known fact, you can actually put these double wides inside these things. Look at that. These inner guides here actually clip out and let you put in double width. And this double width card is really interesting. It's actually a switch. So remember, this is a router. Well, apparently you can just slap a switch in here. It's called the Etherswitch. I suspect these are 10 megabit ports. There's like something in that one. What is that? Coffee bean or something? A viewer named Luke of the Tari actually sent me 2 of these things. And I think they're rather old. I see 1997 codes on the boards here in terms of this 7200 series stuff. And relatively obscure and rare if you're into collecting this. So I'm very happy to have them. Now, they sent them my way because they've got the Cisco VXR series, and you put one of these in, and it just crashes the router. The router won't boot. Won't boot at all. It won't even get into iOS. So I popped it into one of these non-VXR older units, and it booted right up. So if you're going to get deep into this stuff, I guess my point is, it's nice to have a VXR and a non-VXR, depending on how old your cards are. But back to the task at hand, we want to do a point-to-point link over fiber, just an Ethernet fiber cable running to the other router, pretending this is a branch office. I've got this dual port fast Ethernet over fiber port adapter here. I love the ones that are fiber because they put this cool like yellow laser warning thing on there, but it just looks cooler once it's in the machine, you'll see. But I got a problem. All of my fiber cables are like 1 foot, 3 feet long. I just ordered 3 50-foot cables that should work. That'll be plenty to get over there. And in the name of progress, we'll put this fast Ethernet port in there and do it over RJ45 at first, then we'll upgrade to fiber. So let me get these slotted in. We'll put them on the top, I guess. And I'm doing this over fiber to make it slightly more realistic. There is an argument to be made that you might have had fiber coming right to your building. That's very common now, especially interbuilding, like, you know, across a big campus or something. You'd certainly have fiber runs going all over the place between your big aggregation routers. And I'm going to hedge my bets. When I powered this up the first time, this thing appeared to be healthy and functional, but I'm not going to lie, I couldn't figure out quite how to get it to switch, do its job. So we'll put another fast Ethernet port in here in case we need to hook up another switch. I've got plenty of switches, and we're a pretty professional outfit. We'll put the blanking plate in, look good. Don't these things just look so awesome when they start getting the port adapters filled up, especially these double wide ones? So cool. Okay, well, how do you use these things? They've got these input-output controllers on the bottom here. This is our serial connection that we'll hook a computer up to, and we'll control it over the terminal and configure it, and we'll be able to activate all these ports, hopefully, and get them routing the way we'd like. You can see some of these older models use just a larger serial port connector, and that's no big deal. You just slap one of these converters on there. This is a USB to serial converter that I'll use on my main machine in the room with me here. And then we will slap the power on, and hopefully we get a bunch of lights, and it likes all the cards I put inside. I/O power is usually the first thing that comes on here. We can slowly see our cards coming to life as the system is inspecting them. It's not like in this one. Nothing going on, that's a bad sign. We have encountered our first obstacle. Lights never came on this thing, and maybe even worse, when the router boots up, it says it has an unidentified port adapter in that slot. This is always the game you play when you're collecting this stuff and mixing and matching. Does the router physically support what you're putting in it? Does the software running on the router support it? I'm a little surprised. I had a 2003 version of iOS, though there are tons of different variants, so the year doesn't necessarily mean anything. We'll fight that battle later. That's fine. There's plenty of fun to be had with this stuff for now. We're at the serial console of the router. Let's look around here. We're going to issue a show diag. No show inventory here, Cisco fans. This baby's old. And it's going to show us what it thinks is in each port. Slot 0, it sees its own I/O controller, of course. Slots 1 and 2, it sees the Ethernet switch, because it's a dual port card, obviously. Going down a little bit. In slot 4, it sees a fast Ethernet port adapter with one port. That's correct. And in slot 6, it sees another one. And that's it. Nothing in slot 5. That's okay, though. I don't actually know how to do this point-to-point thing anyway, so we'll just do it over Ethernet, play around with this switchboard a little bit. Let's do a show IP int brief. I think this is a totally fresh machine. Yep. Nothing has been configured. I need to plan out my network. All right, here is what I'm thinking. We'll start over here. This is the rack, the main HQ. This is that 7206 VXR in the other room you saw. It's already connected to that 10.0 network with the switch and all the wires going into it on this interface. These are the interface names we'll be using in the configuration. I'm going to add a new network, 172.16.20. I somewhat arbitrarily chose that. And it's got a /30 CIDR notation mask. All this means is that there are 2 available IPs that I can use in this range. I only need 2. One for this thing, and one for this thing. So we're going to use this 172 network, and it's going to be on interface Gigabit Ethernet 02 on the back of that thing. We'll connect an RJ45 cable over to my branch office over here on my left, and I'll connect that to Fast Ethernet 60. These are the physical locations, the actual interface identifiers on the routers, and this is the IP we'll give it. From there, we will allow routing over to the other fast Ethernet port, 4.0. And I chose this 10.0.10 network for my first branch office. We'll use 10.0.20 for something else. And that's the basic idea. When all is said and done, I should be able to get a computer on this network and talk to computers over on the other network through my branch office link, uplink here. This is called a point-to-point link. 2 routers being connected. Let's translate this into reality for this router over here at the command line. This is me over here, by the way. This is the branch office router in the room with me. The first thing we're going to do is configure from terminal, and then we're going to configure the interface we care about. In our case, it's interface, and you can actually tab for completion there, 6/0. That's that top right interface. We're going to give it an IP address, got my notes here, and then the subnet mask is just saying there's only 2 available IPs in this range. And we'll give it a no shut. That stands for no shutdown, the opposite of shutdown. So tells the router, let this interface be online, bring this interface up. And it's already complaining, saying there's no cable connected. What's going on here? So that's fine. Now we're configuring our main router that's in the Retrorack. We're going to do the exact same thing, but assign the right interface, the right IP from my diagram. So we'll do configure from terminal, interface. This one's got gigabit Ethernet interfaces, and we want 0.2. We'll add our IP. I guess it's kind of weird that this one's .2 even though it's the main one, but whatever. I think I did it backwards for my diagram. You know what? Let's fix it. I'll fix the other one. No shut, and that's that. Now I'm going to run a cable between the 2 of them, plug them in. The interfaces should come up, and we can start getting some computers on these things. I have like 15 cables running from this room to the other one, but I didn't label any of them. And I don't think I have any left that can actually reach up into that rack, so I just keep jamming new cables through the wall whenever I need to, and part of this whole project is to inspire me to stop doing that and label everything, but not today. Okay, I just plugged the other end of this cable into the second gigabit Ethernet port. It's been configured to auto-negotiate, hopefully down to fast Ethernet. We might have to do that battle, but let's see if we can get a link established light here. No. Okay, let's try to force the other one to fast Ethernet, not gigabit. This will get you every time. Because I am connecting 2 interfaces directly without an intermediary switch, I need what's called a crossover cable. The wires have to be slightly different for that direct connection. And I've got a little crossover cable adapter here. Let's see. Oh yeah, link established. Green light. On the router in the room, let's try to ping the big one, the HQ. And we can. Okay, that's good. And just for good measure, let's ping the other way into this room. And we can. So what we just did there is establish this line on our diagram. This interface is correct. This one's correct. And now we want to build out a network right here and get some computers moving across, because the end user doesn't really care about this intermediary link. The interesting part is if we're going to be able to traverse through both routers end to end. It's the next day and I'm getting back at this, and I had an epiphany last night. I should rename the host name of each router to match what it actually is. So this is the headquarters router in the rack, as I'm calling it. So we can do, let's call this HQ router. Bam. And now, whenever I'm on the terminal, it's very obvious which one I'm interacting with. We'll do the same thing on the branch office, the first branch office. So we'll say host name, let's call it branch 1 router. There we go. And I've updated the names on our diagram accordingly. Let's build out this network really quick. Should be as simple as setting the IP address to 10.0.10.1. This is going to be the gateway for that network, and we'll do a no shut just for good measure. This is the interface we just configured, and am I thinking about this right? Should it be as simple as throwing it right into this switch module? Maybe. We have a link. I imagine this fast Ethernet can negotiate down to 10 megabit. Well, maybe not. We have no link light here. We do have a link light on this one, so maybe we have to force this to half. I don't even know if this can do 10 megabit. I was messing around a little bit, and I tried to actually bring this up, this 13th port here, and check it out. That switch is complaining that a bridge group must be configured. So I'm going to go learn what that means. I think I figured it out. We'll see. So we're going to turn on bridge integrated routing and bridging on the router itself. I think this is going to let it communicate between the fast Ethernet 4 that it's complaining about, and the switch internally. I don't think I'll have to plug a cable in. We'll see. Another side note, we want to get rid of all these annoying messages coming in automatically. And I think it's no logging console. I think that's going to solve our problem. Now we're going to configure the fast Ethernet interface. We're going to get rid of that IP. There we go. And we're going to give it a bridge group. We'll use 1. Then we'll configure that 13th port. This is making less sense as I do it, but we'll figure it out, I think. We're going to give it the same bridge group. Then we're going to configure this BVI1 interface, and we're going to give it the IP address. And we're going to use the right syntax. Running kind of blind here. I think at this point, if we plug stuff into the switch, it should be able to talk to 10... Oh, I don't know. Okay, I got it working. I'm going to admit it's a little over my head, but it is working. I will put the full configs for everything I'm doing in the description below if you want to poke around and see exactly what I did, but I'll save you the trouble. Notice there's nothing here anymore. We have this internal bridge called 10.0.10.1, and then I have enabled this port. It's connected up to this laptop. You can see this laptop has been set to 10.0.10.2, so it's on the same network. Its gateway is that bridge. And if we ping .1, we get replies. So the switch is actually working. So if you remember back to the diagram, we've built out this right side. We have the link over to HQ. And the problem is, if we try to ping HQ, that router, nothing. We need to set up some actual routes. I know this is a lot of command line time in this video, but we are very close to having our first branch office talking to the HQ. So let's take a look at show IP route. This is the routing table of the branch router. And so it knows about its networks. This 10.0.10 we just set up with the laptop being the one client on it, and then our point-to-point link. Okay, so we need to set up a route that says when you want to talk to HQ machines at 10.0.0.0, you need to go through the link. We're going to create a static route, meaning I'm manually defining it here. And we're going to say, when you try to talk to this network in the HQ, go through our point-to-point link. And now, if we do show IP route, it's a little more interesting. And it says, I know that when I need to get to here, I go through the point-to-point. We'll do the opposite on the HQ router. Not a lot of surprise here. It knows about its own network. It knows it's got this other thing it can link through. Exact opposite static route we're going to set up. On the HQ side, it's going to say, if you need to talk to the branch office network, talk to this guy. And with any luck, if we try to talk to the HQ from this branch office machine, we're getting replies. We have built the branch office network. Over in the headquarters router, let's see if we can ping that Windows XP laptop. And we can. Yeah, I am pretty proud of this. I've never built anything like this before. So like I was saying, this is done with all our routing and everything and our point-to-point connection. Machines on this network can talk with machines on this network and vice versa. Let's build another branch office. Collab Retro Enterprises is growing. We need to open another branch office, and for some reason the executives have decided that they're going to service this branch office to the HQ over T1. T1 is a digital signaling scheme that's been around for decades, and basically it leverages 4 of the wires in a cable like this, meaning I could actually do 2 T1s over this Cat6 cable here, and over each T1 link there's these things called channels, and it's primarily intended, or was I think back in the day, for voice. So you could do 24 phone lines, digital signal phone lines, over one T1 link. T1 can operate at a total speed of 1.544 megabits per second, and you can also dedicate T1 to data, meaning in our case TCP IP traffic. You typically have this equipment called a CSU DSU in the middle. This one happens to be a TSU. It's a CSU DSU with a little more going on. And basically you can sort of think of it as a modem, but it's taking the digital T1 signal in on one side and spitting out a digital signal on the other side that a router can understand. There's a bunch of different connectors you can use for T1. I'll be having an RJ45 cable coming in with the T1 signal from the HQ. And then one option is to use these big V35 serial cables, plug that into your CSU DSU, and then the other end into a serial port on the router. I actually have a video where I did exactly that. So if that sounds interesting, I'll link that in the description down below. You can check that out. I think we're going to try something slightly different today though. Notice this one down here has a modular port, and in that port I believe we'll be able to slide one of these CSU DSU T1 modules. This thing is basically that thing in smaller card form, and the router can natively understand it once we slot it in, and after getting our configuration right, we'll be able to just slap a T1 line right in there. This is a Cisco 1700 series router, a 1721 to be exact, and I'm pretty sure this would have been common fare in a small business or this branch office idea I'm cooking up here back in the early 2000s. On the back, it's got two what are called WAN interface card slots. These are called WIC, WAN interface cards. You already saw me slap this T1 DSU CSU in, and I got a blank one for another one. So of course, business and enterprise routers like this are taking WAN interfaces in, so the internet or other networks. In my case, it's going to be my HQ in the other room, and then routing it to a local network. Right down here, we've got a 10100 Ethernet port, so we'll need to get a switch in the mix. I've got plenty to choose from, so I'll get creative. Oh, and then of course we've got the console port. This is just a serial port in RJ45 form factor there that we can control it locally on the terminal like I was with the big 7200. And most Cisco routers have this aux port. You can actually configure this for remote dial-in over a modem to configure it remotely. Oh, and of course, so that shady asshole over in accounting doesn't walk off with your router, you can use a Kingston lock and lock it to the desk or whatever. Fun little note, you can see it's got these nubs on the top here. So I think you could stack them. And in fact, we can even take that older 1600 series and it stacks in there quite nicely. I don't know why you'd need two of these routers stacked up, but there you go. Cisco was a little creative with their power connectors back then. I think that is a somewhat standard connector, but you're not just going to happen upon one of those power supplies these days. And it's even worse for the older one. Look at that thing. Nightmare. So I'm going to go look for those for 30 minutes. Found it, and look at that. I even labeled it for myself. We've got this Velcro strap around this thing. Who am I? I've diagrammed out the plan, and I'll show it to you before we do the physical stuff. Let me know if it helps or hurts in terms of being able to follow along if I show you this first. So we've built all this out on the right. We did that together. And now we're building the second branch office. What I've done is sort of mapped out how I think it's going to go. We're going to attach a serial T1 interface on each router. These interfaces are serial interfaces for T1, and we're going to use a similar IP scheme. So on this side, for this point-to-point, it'll be 172.16.30. Very much the same as how we did it over here, just a different network with these point-to-point IPs. And then, of course, we've got our router here, and eventually we'll build out a 10.0.20 coming off that fast Ethernet port on the back. So to bring this all together, HQ is the 10.0.0 network, branch 1 is the 10.0.10, branch 2 will be the 10.0.20 over T1. Well, let's see if we can fire up this router, see how it's doing, and then we'll actually go slot a T1 card into the big guy in the rack. Got the power plugged in, and we'll put our serial cable in the console port there and fire this guy up. And the best news for me personally is it doesn't make any noise. It's totally passively cooled, no fans. We can see some power indicators, and it's doing a little light dance as it starts up and loads up the operating system. Here we are on the serial console, and you can see it's booting up, decompressing, I believe, the iOS image to load that up and get us into iOS. That took a solid like 4 or 5 minutes. This thing's running an iOS version from 2010, which I think is quite a bit newer than the unit, but it booted up and it sees our T1 card, which is excellent. That's all we really care about at this point. And if we do a show IP int brief, serial 0 is going to be that card in our T1 connection that we're going to build up here. But before we get into the iOS config, let's get the other router in the right physical condition, and we'll slot this card in there. The router is on. We're going to put this 8-port T1 card in, and these are actually hot swappable. I haven't done this in a while, so you should be able to just slide it in and it'll detect it. Yeah, there we go. I slid my router back there. I'll have to go look and see because now it's off. We'll see what I did there. All right, we're at the console of the HQ router. Let's do a show diag. Okay, It sees it. It knows it's there, but it's saying it's disabled, deactivated, powered off. That's a lot of words to say it's not on. Let's at least do a show IP int brief. And if it was on, I think we would see some serial interfaces here. I'm just going to issue a cold reboot. Yes, that's fine. Confirm. Okay, so that thing's going to reboot itself, and hopefully when it comes back, it leaves that thing powered on. So far, not so good. It says device is not free DM, and it's leaving it powered off. I'm going to go do a little research. That's unfortunate if I have to play some iOS games, or maybe it's not supported, because I think those are the only T1 port adapters I have. I found this PDF, Cisco iOS system error messages, which I've never seen before. I will definitely be saving this. And I've got bad news. When it reports that, it says, contact your Cisco technical support representative. I'm my own technical support. It's possible that card's just bad. Let's pop another one in. Let's try our luck over here and see what we get. I suppose I could have just reseated that thing too, but it doesn't sound like it. This one didn't turn on at all. What does that mean? Round 3. This is not going well. You know, why not? Uh-oh. It really doesn't like one or more of those cards. Now it won't even boot into iOS. It says uncorrectable memory parity error, massive stack traces for all the cards. Oh boy. I'm going to go figure out which card it is and mix and match and see if I can get somewhere. I reseated the original one, left only that one in. The other two are gone now. Did a power cycle of the router. Maybe you're not supposed to hot swap these cards, but it's got the 8 channelized T1 PRI ports. Well, let's see. Show diag. It sees it and it's up. Yeah, maybe I wasn't supposed to hot swap these things. Show IP int brief, of course. We don't have it, but yeah, okay. I just need to figure out how to actually do something with this now. It's all coming back to me. So these things show themselves as what Cisco calls controllers. So I can say show controllers T1, and we can see this is controller T1 in slot 1. That's the slot I put it in, and port 0 is down, port 1 is down, all the way through port 8. I'm going to get this thing configured, and I've already covered pretty in-depth in another video how to do a point-to-point T1 link, and I'm going to go get all this wired up. I'll of course put my final configs in my GitHub, link down in the description. Got that all wired up, and if we do one of these, we can see I now have a serial interface on port 0 of that card, and it's using our point-to-point IP that we want. I just did the corresponding config for this T1 CSU DSU card in here. This is a T1 line going back to the T1 module in the HQ we just configured, and with any luck, we're going to plug this in and see some good green lights go on here. I think that's a good sign. The link line for the T1 port on the rack also came on. Back over here on the branch 2 router, right here in the room with me, it's got this IP, but can we ping HQ over our T1 link? We can, yes. All right, this means I don't have to debug this for another 2 hours. So we've configured the point-to-point T1 link. I updated all the interface names here, and the eagle-eyed out there will notice I used the wrong IPs in my initial configuration. I fixed that on both routers. Now we need to build out this network over here. And for that, we're going to need a switch. This one might kind of ruin my quaint branch office motif I've got building up over here, but that's okay. Like I said, I just want to mess around with this stuff. A viewer named 2DFX sent me this for the cost of shipping, along with a lot of other interesting items. So a huge thanks to them, and it's in an original Cisco box. I don't know if it's the same box this thing came in, but I obviously haven't opened it up yet. Let's have a look at what we've got. Well, maybe it was the original box. It is another Catalyst 3500 Series XL. I think it's identical to the one I've got in the rack over there at HQ. So, you know, we bought them in bulk. We ship them to the branch offices, and it is in excellent condition. Well, let's wire up our local network on this guy. I think you know the drill by now, but we're building up some muscle memory together. So this thing has one fast Ethernet interface. I think we wanted 10.0.20.1 on this bad boy. Let me know and continue to provide feedback on whether or not this command line stuff is interesting. I know it can be a little bit of a slog sometimes. Let's bring it up. And now, similar to our other point-to-point, we were setting up over just the Ethernet cable. We've got our local network here and our point-to-point, but we haven't done the routing yet. So remember, I made static routes to let this network talk to this one over in HQ. And we're going to do the same thing here. Let this one talk to this one. And I'm also going to wire up static routes so that this one knows how to get all the way over here, and we'll test that. That'll be the final test. Can all three of these networks talk to each other? I'm going to wire that up now, and then we'll get a computer on the switch. I'll show you how I'm going to wire up the routes on this branch router in the office with me here. Branch router number 2, branch 2. So it's saying if you need to talk to HQ, you need to go through your point-to-point T1 link. But if you also want to talk to the first branch office, which is on this 10.0.10 network, you also need to go through that link because the HQ knows how to get you there. To test our routing setup, we've got this Windows 7 laptop. Some interesting choices being made by the IT folks for this particular branch office. Got the router hooked up to this switch. The computer, of course, is also hooked up. It's on the right network. Its IP is 10.0.20.2. I didn't even look at the switch. I didn't go in the console at all. I'm pretty sure it's been factory reset and it's just going to switch, I think. First test, can we ping the router that's sitting on the desk connected to the switch? And we can. So the local area network of branch office 2 is working. But the real test is going to be, can we ping the headquarters? Yeah, and we can. I hadn't tried that yet. That's pretty exciting. So branch 2 can talk to HQ. The final test, can the branch offices talk to one another through the headquarters? We've got branch office 1 set back up in a totally different location. It was actually non-trivial to get this Ethernet all the way over here. So hopefully this is enjoyable, and my wife will be very impressed if she happens to come down. Remember, this computer here is the first branch office that we set up. Let's see if we can ping each HQ. I was already doing a couple HQ pings, and we can. But the real test is, can we ping, let's start with the router we just set up in the second branch office. Oh, we can. This is looking good. Now, the final test. Can we talk to that Windows 7 machine in the other branch office? And we can. We've gone from branch 1 through 3 routers over to branch 2. For completeness, back in here, let's try to ping the Windows XP machine we were just on in the other network, because the routing rules do have to go both ways. And we're getting replies. All right. Just to get a feel for what this T1 connection is all about, I've got iPerf running on the Windows XP machine in server mode. iPerf is a network latency testing tool, and we're going to connect to it from here over our T1 link, obviously. And it's going to go off and try to do some stuff. And yeah, you can see we're topping out at the full T1 speed, 1.55 megabits per second. That's pretty cool to see. My 50-foot fiber cables did show up, but I think we're going to save the fiber stuff for a future video. Doing that is basically going to be the same configuration and physical setup as that Ethernet cable. We'll do more interesting stuff with fiber, exploring ATM as a backbone in the future. Speaking of ATM, a lot of what I've done here isn't, strictly speaking, very realistic, because remember I was saying before, you'd have an ISP between your headquarters and your branch offices. I'm operating as my own ISP. The T1 is arguably accurate because it would come to your office in a similar fashion, but like the point-to-point Ethernet, that's not how an ISP works, obviously. So we're going to explore different backbone technologies like asynchronous transfer mode networks. So in the future, we'll get a section of the Retrorack dedicated to ISP type networking behavior. But we got this network completely set up with the 2 branch offices. But there's a lot more to do. We didn't cover DHCP, so dynamically assigning addresses as computers come online. The HQ router actually already can do that, but I didn't do it at the branches, and I haven't decided how I'm going to like proliferate all that in general. I was also showing you that Sunfire server, which hosts the Sunray server software for those thin clients. Those require DNS to work properly, and I'd really like to get thin clients on each of the branch networks and get them networked up. I think that would be a really fun video, and it will require setting up a DNS server, which will get dedicated into the Retrorack. It's pretty much endless stuff to explore now. I didn't really know how to set all this up by hand when I started, so it's been a good learning experience for me. You can actually do more dynamic routing. You don't have to sit there and like type in the routes. You can teach the routers to chat with each other and learn routes dynamically. So we'll probably upgrade to that in the future. But if you made it this far, I hope you enjoyed this whirlwind of networking. We covered a lot of ground. We looked at tons of equipment, and I've got more plans on the way. There is basically an endless amount of stuff we could explore now that we have this more complex network going. If you'd like to help me keep buying gear and growing this network, and just support the channel in general, I have a Patreon page with behind the scenes, occasional early videos, and for $5 and up, you get access to the Serial Port Discord, where I hang out quite a bit. As always, thank you so much for watching. I hope you enjoyed the video. I've got more on the way, and I'll see you in the next one.